Okay, so these are representatives of these protocols that you need to know about. And yes, don't get me wrong, you do have to understand these. It's in your book as well. Okay, so then there isn't really much that they're going to ask you about BGP. Just know that it is a exterior gateway protocol where you ship packets across the across the AS network. Okay, on the outside. And inside the ASs, you will use either RIP, OSPF, or EIGRP, or a combination of these. You can, yes, one router can be speaking two different languages when they talk to routers. Okay? So, but what doesn't change is they all tries to figure out what is the cheapest way. And when they talk about cheapest way, okay, if we look back into the routers, okay, each router makes its own decision as to where to send next, to which router do it send next in a path. That means they're making a path decision on its own, okay? But the decision comes from one place. It's called the routing table. So every router is going to have a routing table, right? So every router has a routing table. Okay, everybody's going to have a routing table. Everybody. Okay, so because everybody has a routing table, and the routing table tells the router to send which router to send to next. In order, let's say if A wants to talk to B, which router do I have to send? Do I send to router 2 or router 3? That decision is based upon the routing table, and the routing table has the information that tells the router what is the cheapest route. Okay, and for example, these are called metrics, right? So metric. So the RIP metric, if you're using RIP, it's a very simple protocol, but it's very, very chatty. It has a lot of downfalls. We'll talk about it a little bit later on, not right now. But RIP will consider what's called hops as the cost, right? They keep number of hops as metric, and hop is a router. So if A to go to B, if one route takes 5 hops, let's say 5 routers, and the other one takes 10 routers to go to 10 hops, then it's always going to choose the least hop route. So it's going to always take the 5 route. So if you have, I've just scrolled again, okay, and I'm going down to the bottom. If you have a router, let's say, here you are, here's A, okay, you're connected to the default gateway, and the default gateway, let's say, is connected to 2 routers, and here's B, okay? If you use RIP, right, as a routing protocol, if that's the language you choose, it's always going to choose this route, because you see there's 1, 2, 3 hops rather than 1, 2, 3, 4 hops, okay? Thing is, sometimes this could be too simplistic, in that, what if this route right here is a satellite link? Satellite, really, really slow. I tried to do a satellite, sorry about that. That's a poor excuse for a satellite, but it's a very slow link, So maybe, going around the top way, going through 4 routers could be faster, right, than going down, because one is a satellite link, which is very slow. But RIP doesn't have the intelligence to say, nope, I'm not going to go through it. RIP will go to, it just counts routes, routers. It's as simple as that. Whereas OSPF, if your router is able to speak OSPF, then it will take the fastest path. Okay, that's the cost. So they'll look at the bandwidth, and they'll take the best route based on the bandwidth. Okay, so that's OSPF. OSPF is very, very smart, and EIGRP has multiple metrics that they follow. Okay, and another advantage with OSPF, right, is that well, let's look at the disadvantage of RIP. So one, RIP does not take latency into account. Okay, and RIP routers will actually chat with each other constantly. They'll talk to each other whether they need to talk to each other or not, like every 30 seconds. Okay, and every 30 seconds, it actually sends the entire routing table to the other party. So here's my routing table. 30 seconds later, here's my routing table. So its hope is that when the other router receives a routing table, that it's going to say, okay, so do I need to update anything? Nope. Do I need to update anything? Nope. Do I need to update anything? Yep. And then update something on their routing table. Okay. But the more efficient way to do this is send the changes that happens. So let's say if a link goes down, then everybody needs to know that the link went down, so they don't take that route or send anybody through that link until it comes back again, right? So whenever something like that happens, then send that information out. Say, hey, look, link 1 just went down. Please update your routing tables. But RIP doesn't. RIP just says, I'm just going to send my routing table whether I need to or not. And sometimes I've seen the network just come down because there are just too many RIP exchanges. It's that bad. Okay, it's a lot of overhead. Whereas OSPF, when it first comes up, that's when you power it on. Yes, it's going to go through something called, it's going to find a neighbor that they want to talk to, and it's going to send its routing table at that point. But going forward, it's only going to send the changes, any modification that needs to happen to the neighbors, right? So it's very efficient, okay? But the thing is, what if the router goes down, right? If the router goes down, you're not going to hear from that router. So there's got to be another way to find out. It says, well, no news is good news. That's not the case with OSPF. So OSPF will send something like a ping to make sure that everybody's alive. So it's a very lightweight, communication. Say, hey, ping, 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 and then whenever something changes, here's the changes, right? Here are the changes. In addition to that, there is a authentication feature. So you define something called the area, the neighbor area, and if you're not in the area, then you don't get to communicate with those other routers. And you can actually put a password to it, so the rogue router cannot come in and try to mess up all your routes. So there are all kinds of advantages to the OSPF. One disadvantage to the OSPF is that it does take some skill to set this thing up. It's almost like, you turn it on and it works. But with OSPF, you do have to configure. So that would be a downside. So there you go. That's how the routing protocols basically works. Okay. Oh, by the way, one more thing. Let's say the router goes down or the link goes down. Okay. And everybody in this conversation has to understand that those two things happen. Router and the link went down. Okay. In the time that it takes for all the routers in the conversation to understand that this happened is called convergence. Convergence. Compared to OSPF, RIP takes a long time to converge. So OSPF is much more efficient in convergence too. So if it doesn't converge quickly, what happens is that you got packets just, being dropped into the black hole, because somebody thought that link was open and sent something, but the link wasn't available. You see, so that's also important as well. Convergence. Okay, let's see. So that is on the network layer. I know I had to kind of cram that information in there, and using the new whiteboard too. So any questions on the route, and also the network layer? Okay, so when we talk about this one more time in day 3, so tomorrow, I think the latter part of tomorrow, we're going to be finishing off the network part. We will revisit this again very lightly, okay? But then we will talk about the security issues that can happen at the network layer at that time. Okay, because I think before lunch I want to complete this OSI thing. Okay, so the next layer then, if there are no questions, is the transport layer. Okay, the transport layer. So here we go. There it is. Transport layer. Can anybody tell me, what happens at the transport layer? Any ideas? I know it's 10 minutes to lunch, but still got 10 minutes. Yeah, Lisa. handles the order and delivery. Ah, yeah, there you go. Exactly, right? So it basically handles the error checking, error correction, so error detection, error correction, and the flow control, right? That's basically what a transport layer does. And what happens is, remember the data that comes down? Right, we had data up here someplace. Let me see here. We have data. Okay, when it comes down, these data could be broken into pieces. And the transport layer said, hey, ship them all to, from A to B. Okay. But they said something like, okay, so you have to come in order. So order 1, 2, and 3. So 3. So when you get to the other side, make sure that you order yourself back up into, 1, 2, and 3. So during the transport, if something goes missing, let's say 2 doesn't come in, the transport layer says, look, I'm missing 2. So send everything after, including 2. So that will be error detection, error correction. It's disassembly at this end, assembly at this end. Okay, so in that way, it's error detection, error correction, and flow control. It says, okay, I'm going to send these things out in pieces. So that's basically a transport layer. And when you look at the TCP/IP of the transport layer, it contains information such as port, okay, and protocol. Okay, so some of the devices that you find at the transport layer is, I think Terry kind of mentioned that it's firewall, because now you add not only the IP addresses that you find at the network layer, but now you say port address and the protocol. So now the firewall can say, look, where are you going? Oh, to this IP address. Okay, in which service in that IP address? Well, port 80. Okay, and using what protocol? What TCP? Okay, so then you say, okay, so basically you want to talk HTTP, you can go, right? So then somebody else comes and say, where you want to go, same IP address. Okay, which service? Port 21. Whoa, okay. What is the protocol? TCP. So you want to do FTP? No, you can't go. Okay, so now you could do finer grained filtering compared to what you could have done at the network layer. Okay, so that would be an example of an extended ACL for a router. A router can have something called extended ACL that takes into account the IP address, source and destination, and the source port. I'm sorry, destination port. Okay, sorry about that. Destination port and the protocol itself. Okay, so it's more finer grained. But these two types of the firewalls are called packet firewalls. Mainly because these firewalls are only concerned with the packet that's right in front of them. Okay, nothing before, nothing going after. There's no connection between what came before and what's going to come after. It just looks at that packet as it goes through and say, look, what IP address, what service, what port, what what protocol. That's basically what they're looking for. So it's a one-shot deal. Okay, so it's nice, but it's pretty simple. Okay? There's no concept of session, for example. Okay, so that would be the transport layer. Right? Any questions on the transport layer? Okie dokie. All right, so then the next thing then is the session layer. Okay, remember session layer is layer 5. Transport layer is layer 4. Network layer is layer 3. Data link layer is layer 2. And physical layer is layer 1. And of course we have 6, 7, and 8, right? And of course we have no 8. Check to see if you're awake, right? So, all right. So the session layer, what does the session layer do? What's its function? Session management. Okay. So can you describe what a session is, Lisa? Okay, all right. All right, so this is what happens. Let's say session. So here's a very simple example. Let's say you are on, I just opened up a new sheet. So let's say you are on a computer that's connected. Okay. And let's say you are accessing, because now you have a modern browser that has tabs. So you got tab 1, tab 2, tab 3. Okay. And you're connected to server 1, 2, server 3. Let's say one's CNN, and the other one is eBay, the other one is Google. Okay. And you have these CNN, I don't know what. Let's say I'm attached to Google, second one to eBay, and the third one to CNN. Okay, so these tabs, different sites. These are sessions. Okay, but if you don't have session management, as Lisa just mentioned, what would happen is that, let's say the top page that has a Google, when you search, the search result comes back and destroys your CNN page, and your CNN update comes up on your Google page, and eBay, God knows where it goes to. Okay, so if you don't have session management, that's basically what happens. You'll just like mess up. You'll never know which tab you're going to have these things coming back on, if at all. Okay. So what that means then is that we actually have to identify what's called the session endpoints, right? So that we can clearly define what a session is. So session endpoints define each of the sessions. Okay. And session endpoints has to be uniquely identified. Okay. And in TCP/IP, session endpoints are identified using 3 values that will make it unique. I'll give you a hint. One is an IP address. Okay? But as you can see on this tab, they're all on the same PC, so they all have the same IP address. So that is not going to make it unique. What do you think other 2 things are that will make this thing the whole thing unique? What will be the 2 other pieces of information that you need for the session endpoint? Okay. I'm going to give you another one. The other one is called the protocol. Okay? So is it HTTP? I'm sorry. If it's HTTP, it would be something like TCP. So it'd be, is it TCP? Is it UDP? Is it ICMP? Well, ICMP actually don't have a session. So yeah. So that's basically a protocol. Okay? So what do you think the last value is to make this whole thing unique? I will wait 3 seconds. 1001, 1002. Yeah. Authentication? What would authentication give you? Because I'm just looking for a value. Authentication is a process. So what does that give you? Yeah, no problem though. So the session endpoint, I understand. In order to create a session, you mean you probably need to authenticate. Yeah, I understand that. But the session endpoints though has little to do with authentication. It's TCP/IP. So it actually needs to have, yeah, Dave, MAC address. No, no, not MAC address. Because the MAC address would be the same, right? Okay. So because we have the IP address, MAC address will still be the same. So that's not going to be unique. The BIOS name. No, this is for TCP/IP. It could be true, Lisa, on the BIOS. Yeah. Authorization. Okay, I see you guys are going. No, let me just give Terry. It's been since the 90s. Yeah, that's no problem. Port. And you say, the port. Yes, right? So the combination of IP address, the protocol, and the port will give you a unique endpoint. And right before we go to lunch, I just want to show you what that looks like. Okay, so let me show you what that looks like. And then we will go to lunch and pick up where we left off. Okay, so I hope you see the you see my command prompt. Okay, so I have more than several tabs open on my browser. So if I do, just ignore these because these are they're just local. But this will show you the session endpoint and the protocols. And notice on the left hand side it says protocol, right? Protocol, and you see TCP. Local address, foreign address. So that would be the IP addresses on both sides. And then after the colon on the right-hand side, what you see are the port addresses. So let's take a look at I'm going to wait. Let me see. And also the state, it'll tell you the state of the session. So take a look at third from the bottom, right? Third from the bottom. So my address is 192.168.1.138. That's my IP address. And I am using port 51,418. Okay. And on the other side, I have EC2, 5. Whatever. That's actually AWS. And then on the side of the colon is HTTPS. So that's shorthand for 443. And then established. See? So that is a session. And notice all the three elements are present. So you have the IP address, you have the port address, and you have the protocol. And once you have that, now you have the endpoints. Okay, so that's a session. So that's a connection, isn't it? Right? All right. So now let's get back to the. Okay. So the session, right? Session layer, okay, maintains a session, doesn't it? And in fact, if the protocol requires it, for example, UDP, User Datagram Protocol, and TCP/IP does not have a concept of a session, so it's not going to have a session here. But TCP, Transmission Control Protocol, does, right? It's the one, it's called the Connection-Oriented Protocol. So it is going to look at the session, okay? So that's basically a session layer, okay? So just one last question. What device would you think that you can find at layer 5, at session layer? Computer. Very. Okay. Could you be a little more specific? What operates at that layer 5? Because you see, computer actually operates at much higher layer. Operating system. Operating system is above layer 7, isn't it? Yes, it does, Lisa. So firewall still apply, but what type of firewall? There are two different types of firewall. One is a stateful firewall, and the other one is stateless firewall. Stateful firewall, very good, that's right. Because the state is about session, isn't it? So now you have a firewall that's actually looking at the session information and saying, look, you know, what are you trying to do? Are you trying to create a session? Are you in a session? Are you trying to get out of session? Or are you just trying to attack somebody? Okay, so yeah, and the stateful firewalls starts at layer 5, okay? And it's also called the circuit, right, firewall, circuit, because it creates a circuit, doesn't it? Where the session is like a circuit. So this is also called a circuit firewall. Okay, that's layer 5. And when we come back, return from lunch, we will continue on with the layer 6, 7, and go into our first domain. Right? So 6 and 7 is very easy. It's very fast. So it'll probably finish within 30 minutes or so. Alrighty, any questions on anything we covered this morning? It's pretty heavy duty, I think, if this is the first time you've encountered something like this. And I'm hoping, though, that this will kind of give you a step up when you start to read your book, and a lot of things will make sense. Okay. Yeah. Oh yeah, so I've actually deleted some, but I do have some that's left over. Yep, at the end of the day, I'll give this to you in PDF format. Would that be okay? Okay, sounds fine. All right, so I see you guys after lunch. See you in 60 minutes. All right, please have a nice lunch. Bye bye.